So I want to talk a little bit about the concept of integrated geospatial services and the many components of an integrated geospatial service and what this might mean for FPAC for their enterprise foundation. So the idea of integrated geospatial services can provide FPAC with a whole range of approaches that could help them fully meet their mission objectives. So I think there's three functional areas of integrated geospatial services: data services, then there's geospatial tools and applications, and then the third area is what we call shared services. So the first area I want to talk about is data services, and this talks about acquiring and maintaining and serving out multiple data sources. So by having multiple data sources, it provides the ability to have consistent and authoritative data layers, and these data layers will help with decision making down the road. And within FPAC, we know that there's a demand for integrated data collections. So these data services, again, are going to form the foundation for web mapping and for cartographic visualization. For our NAVFAC Northwest Geo Readiness Center, we made data services a core element in managing their GIS. So we help them support regional data stores, and we help them support quality control objectives within their geospatial data. So it was a very important concept. The next service is applications and tools, and this is a broad area where geospatial tools can enrich geospatial data. And by enriching geospatial data, you accelerate the understanding and you help facilitate decision making. And a prime example here is geo-orthophotography. This is aerial imagery that receives a spatial reference, and now this can be used as a backdrop or a cadaster for GIS. So here, FPAC can bring in different types of imagery like LiDAR, like infrared imagery, like visible imagery. And these types of concepts could support programs like the National Aerial Imagery Program or the National Resource Inventory and Stewardships of Lands. So the very last area, the third functional area, is what we call shared services. And this is where Esri web applications, web mapping platforms can all be built. And this is where FPAC, they can publish and they can make their data available to the public or to other stakeholders, and they can do this in a secure cloud environment. So when we think of shared services, the shared services functional area, this is the pathway to a well-developed geospatial web portal and well-developed geospatial web services. So I just scratched the surface of an integrated geospatial foundation, but I hope that you can see the impact that this sort of framework could have.
Years, supporting 80% of the national geospatial data assets and programs. Actually, it started in 2005, where we supported the Department of the Interior Geospatial Services Blueprint, which covered about 50% of those. Since then, we've been able to help in establishing vision and roadmap, establishing agile best practices, heavy lift development, proof of concepts and GIS operations supports in areas such as the United States Forest Service National Geospatial Services, USGS National Map and National Geospatial Program, EPA's National Geospatial Program, Bureau of Land Management, CETA efforts, and several others. We're also currently supporting geoplatform.gov and data.gov to help with cross-federal integration. Point being,
we know the geo industry. We know data acquisition, collection, integration, service delivery. We know how to build data supply chains. We know how to build operating models at scale. Currently, we're moving our land and resource management customers to knowledge-centric architectures based on geocomputational analysis and machine learning.
okay, top geospatial architecture trends. Cloud serverless data pipelines, number one. Connect various ELT over ETL workflows. Metadata updates trigger GIS product and service generation. Those files are updated, which triggers data quality and compliance report refresh. Really scalable, lower cost, no idle servers and licenses. Number 2, microservice architectures to integrate operational data stores. Lowers disruption. Mission folks tend to like that. Number 3, while there's still some gotchas, moving to application configuration with ServiceNow, Salesforce, Esri ArcGIS Online, over high custom app development, speeds time to market, and lowers risk. Number 4, IOT stream hubs to handle that sensor noise, increase high data fidelity, and make the data earlier and available to analytics. Number 5, let's get the data scientists analyzing earlier by making cloud containers, putting a bunch of them together in a cloud workbench. Each of them might be set up to hold different data slices and their favorite data science tools. R, Carto, MATLAB, Esri, Power BI, CAD, etc. As a bonus one, number 6, moving from traditional structured warehouse analytics to native data and graph theory. Those type of models can support more advanced analytic approaches such as AI, machine learning, deep learning, neural networks.